Earth is the planet we live on, the third of 8 planets in our solar system, and the only known place in the universe to support life. Earth. The spectacular blue marble image is focused on Eastern Africa and Asia's Indian subcontinent. In addition to the dark blue of the Indian Ocean, the lighter blue of East Africa's Great Lakes are also visible. Earth is the third planet from the Sun, after Mercury and Venus. And before Mars, it is about 150 million kilometers, about 93 million miles from the Sun. This distance, called an astronomical unit O, is a standard unit of measurement in astronomy. Earth is 1 from the Sun. The planet Jupiter is about 5.2 astronomical units from the Sun, about 778 million kilometers for 183.5 million miles. Earth is the largest and most massive of the rocky inner planets, although it is dwarfed by the gas giants beyond the asteroid belt. Its diameter is about 12,700 kilometers, 7,900 miles, and its mass is about 5.97 times 1024 kilograms, 6.58 times 1021 tons. In contrast, Jupiter, the largest planet in the solar system, has a diameter of 143.0 kilometers, 88,850 miles, and its mass is about 18,981,024 kilograms, 209,310 tons. Earth is an oblate spheroid. This means it is spherical in shape, but not perfectly round. It has a slightly greater radius at the equator, the imaginary line running horizontally round the middle of the planet. In addition to bulging in the middle, Earth's poles are slightly flattened. The geoid describes the model shape of Earth and is used to calculate precise surface locations. Earth has one natural satellite, the Moon. Earth is the only planet in the solar system to have one moon. Venus and Mercury do not have any moons, for example, while Jupiter and Saturn each have more than a dozen. Planet Earth. Earth's interior is a complex structure of superheated rocks. Most geologists recognize 3 major layers: the dense core, the bulky mantle, and the brittle crust. No one has ever ventured below Earth's crust. Earth's core is mostly made of iron and nickel. It consists of a solid center surrounded by an outer layer of liquid. The core is found about 2,900 kilometers, 1,802 miles below Earth's surface, and has a radius of about 3,485 kilometers, 2,165 miles. A mantle of heavy rock, mostly silicate, surrounds the core. The mantle is about 2,900 kilometers, 1,802 miles thick, and makes up a whopping 84% of Earth's total volume. Parts of the mantle are molten, meaning they are composed of partly melted rock. The mantle's molten rock is constantly in motion. It is forced to the surface during volcanic eruptions and at mid-ocean ridges. Earth's crust is the planet's thinnest layer, accounting for just 1% of Earth's mass. There are 2 kinds of crust: thin, dense oceanic crust, and thick, less dense continental crust. Oceanic crust extends about 5 to 10 kilometers, 3 to 6 miles beneath the ocean floor. Continental crust is about 35 to 70 kilometers, 22 to 44 miles thick. The crust is covered by a series of constantly moving tectonic plates. New crust is created along mid-ocean ridges and rift valleys, where plates pull apart from each other in a process called rifting. Plates slide above and below each other in a process called subduction. They crash against each other in a process called faulting. Tectonic activities such as subduction and faulting has shaped the crust into a variety of landscapes. Earth's highest point is Mount Everest, Nepal, which soars 8,850 kilometers, 29,035 feet in the Himalaya Mountains in Asia. Mount Everest continues to grow every year, as subduction drives the Indo-Australian tectonic plate below the Eurasian tectonic plate. Subduction also creates Earth's deepest point, the Mariana Trench, about 11 kilometers, 6.9 miles below the surface of the Pacific Ocean. The heavy Pacific plate is being subducted beneath the small Mariana Plate. Plate tectonics are also responsible for landforms such as geysers, earthquakes, and volcanoes. Tectonic activity around the Pacific Plate, for instance, creates the Ring of Fire. This tectonically active area includes volcanoes, such as Mount Fuji, Japan, and earthquake-prone fault zones such as the west coast of the United States. Earth is a rocky body, constantly moving around the Sun in a path called an orbit. Earth and the Moon follow a slightly oval-shaped orbit around the Sun every year. Each journey around the Sun, a trip of about 940 million kilometers 584 million miles, is called a revolution. A year on Earth is the time it takes to complete one revolution, about 365.25 days. Earth orbits the Sun at a speedy rate of about 30 kilometers per second, 18.5 miles per second, at the same time that it revolves around the Sun. Earth rotates on its own axis. Rotation is when an object, such as a planet, turns around an invisible line running down its center. Earth's axis is vertical, running from the North Pole to the South Pole. Earth makes one complete rotation about every 24 hours. Earth rotates unevenly, spinning faster at the equator than at the poles. At the equator, Earth rotates at about 1,670 kilometers per hour, 1,040 miles per hour, while at 45 north. For example, the approximate latitude of Green Bay, Wisconsin, United States, Earth rotates at 1,180 kilometers per hour, 733 miles per hour. Earth's rotation causes the periods of light and darkness we call day and night. The part of Earth facing the Sun is in daylight. The part facing away from the Sun is in darkness. If Earth did not rotate, one half of Earth would always be too hot to support life, and the other half would be frozen. Earth rotates from west to east, so the Sun appears to rise in the east and set in the west. In addition to Earth's revolution and rotation periods, we experience light and darkness due to Earth's axis not being straight up and down. Earth's axis of rotation is tilted 23.5. This tilt influences temperature changes and other weather patterns from season to season. Earth's physical environment is often described in terms of spheres: the magnetosphere, the atmosphere, the hydrosphere, and the lithosphere. Parts of these spheres make up the biosphere, the area of Earth where life exists. Earth's magnetosphere describes the pocket of space surrounding our planet where charged particles are controlled by Earth's magnetic field. The charged particles that interact with Earth's magnetosphere are called the solar wind. The pressure of the solar wind compresses the magnetosphere on the day side of Earth to about 10 Earth radi. The long tail of the magnetosphere on the night side of Earth stretches to hundreds of Earth radi. The most well-known aspect of the magnetosphere are the charged particles that sometimes interact over its poles through auroras, or northern and southern lights. Earth's atmosphere is a blanket of gases enveloping Earth and retained by our planet's gravity. Atmospheric gases include nitrogen, water vapor, oxygen, and carbon dioxide. The atmosphere is responsible for temperature and other weather patterns on Earth. It blocks most of the Sun's ultraviolet radiation (UV), conducts solar radiation and precipitation through constantly moving air masses, and keeps our planet's average surface temperature to about 15 Celsius 59 Fahrenheit. The atmosphere has a layered structure. From the ground toward the sky, the layers are the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Up to 75% of the total mass of the atmosphere is in the troposphere. Where most weather occurs, the boundaries between the layers are not clearly defined and change depending on latitude and season. The hydrosphere is composed of all the water on Earth. Nearly 3/4 of Earth is covered in water, most of it in the ocean. Less than 3% of the hydrosphere is made up of fresh water. Most fresh water is frozen in ice sheets and glaciers in Antarctica, the North American island of Greenland, and the Arctic. Fresh water can also be found underground, in chambers called aquifers, as well as rivers, lakes, and springs. Water also circulates around the world as vapor. Water vapor can condense into clouds and fall back to Earth as precipitation. The hydrosphere helps regulate Earth's temperature and climate. The ocean absorbs heat from the Sun and interacts with the atmosphere to move it around Earth in air currents. The lithosphere is Earth's solid shell. The crust and the upper portion of the mantle form the lithosphere. It extends from Earth's surface to between 50 and 280 kilometers, 31 to 174 miles below it. The difference in thickness accounts for both thin oceanic and thicker continental crust. The rocks and minerals in Earth's lithosphere are made of many elements, rocks with oxygen and silicon. The most abundant elements in the lithosphere are called silicates. Quartz is the most common silicate in the lithosphere and the most common type of rock on Earth. Almost all materials on Earth are constantly being recycled. The three most common cycles are the water cycle, the carbon cycle, and the rock cycle. The water cycle involves three main phases, related to the three states of water: solid, liquid, and gas. Ice, or solid water, is most common near the poles and at high altitudes. Ice sheets and glaciers hold the most solid water. Ice sheets and glaciers melt, transforming into liquid water. The most abundant liquid water on the planet is in the ocean. Although lakes, rivers, and underground aquifers also hold liquid water, life on Earth is dependent on a supply of liquid water. Most organisms, in fact, are made up mostly of liquid water, called body water. The human body is about 50% to 60% body water. In addition to survival and hygiene, people use liquid water for energy and transportation. The third phase of the water cycle occurs as liquid water evaporates. Evaporation is the process of a liquid turning into a gas, or vapor. Water vapor is invisible and makes up part of the atmosphere. As water vapor condenses, or turns back into liquid, pockets of vap. The carbon cycle involves the exchange of the element carbon through Earth's atmosphere, hydrosphere, and lithosphere. Carbon, essential for all life on Earth, enters the biosphere many ways. Carbon is one of the gases that make up the atmosphere. It is also ejected during the eruption of volcanoes and ocean vents. All living or once living materials contain carbon. These materials are organic. Plants and other autotrophs depend on carbon dioxide to create nutrients in a process called photosynthesis. These nutrients contain carbon. Animals and other organisms that consume autotrophs obtain carbon. Fossil fuels, the remains of ancient plants and animals, contain very high amounts of carbon. As organisms die and decompose, they release carbon into the ocean, soil, or atmosphere. Plants and other autotrophs use this carbon for photosynthesis, starting the carbon cycle again. The rock cycle is a process that explains the relationship between the three main types of rocks: igneous, sedimentary, and metamorphic. Unlike water in the water cycle or carbon in the carbon cycle, not all rocks are recycled in different forms. There are some rocks that have been in their present form since soon after Earth cooled. These stable rock formations are called cratons. Igneous rocks are formed as lava hardens. Lava is molten rock ejected by volcanoes during eruptions. Granite and basalt are common types of igneous rocks. Igneous rocks can be broken apart by the forces of erosion and weathering. Winds or ocean currents may then transport these tiny rocks, sand and dust, to a different location. Sedimentary rocks are created from millions of tiny particles slowly building up over time. Igneous rocks can become sedimentary by collecting with other rocks into layers. Sedimentary rocks include sandstone and limestone. Metamorphic rocks are formed when rocks, Earth and the rest of the solar system, formed about 4.6 billion years ago from a huge, spinning cloud of gas and dust. Over a period of about 10 million years, the dense center of the cloud grew very hot. This massive center became the sun. The rest of the particles and objects continued to revolve around the sun, colliding with each other in clumps. Eventually, these clumps compressed into planets, asteroids, and moons. This process generated a lot of heat. Eventually, Earth began to cool and its materials began to separate. Lighter materials floated upward and formed a thin crust. Heavier materials sank toward Earth's center. Eventually, three main layers formed: the core, the mantle, and the crust. As Earth's internal structure developed, gases released from the interior mixed together, forming a thick, steamy atmosphere around the planet. Water vapor condensed and was augmented by water from asteroids and comets that continued to crash to Earth. Rain began to fall. Eras on Earth. Paleontologists, geologists, and other scientists divide Earth's history into time periods. The largest time period is the Superian, and only applies to one unit of time, the Precambrian. Eons, eras, and periods are smaller units of geologic time. Most of Earth's history took place in the Precambrian, which began when Earth was cooling and ended about 542 million years ago. Life began in the Precambrian, in the forms of bacteria and other single-celled organisms. Fossils from the Precambrian are rare and difficult to study. The Precambrian Superian is usually broken into three eons: the Hadean, the Archean, and the Proterozoic. We are currently living in the Phanerozoic eon. The first major era of the Phanerozoic is called the Paleozoic, and the Cambrian is the first period of the Paleozoic era. The Cambrian explosion of life was the rapid appearance of almost all forms of life. Paleontologists and geologists have studied fossils of archaea, bacteria, algae, fungi, plants, and animals that lived during the Cambrian period. The Cambrian was followed by the Ordovician, Silurian, Devonian, Carboniferous, and Permian periods. The Mesozoic era began about 251 million years ago. This was the era when dinosaurs flourished. The Mesozoic has three periods: the Triassic, the Jurassic, and the Cretaceous. We currently live in the Cenozoic era, which began about 65 million years ago. The Cenozoic is generally marked by three periods: the Paleogene, the Neogene, and the Quaternary. We live in the Quaternary period, which began about 2.5 million years ago. All ancestors of Homo sapiens, modern humans, evolved during the Quaternary.